There we go. All right, just making sure that the audio is still working, and we're all set. So, this is what we're going to do for the lab assignment. So, although you can still work through the book, and actually the assignments are based on assignments from the book, this is what you'll actually turn in. Now, the numbers here are meant to be 1, 2, and 3 are meant to represent that you'll be turning in 3 scripts. The bullets here are more explanations of 1. Okay? So you've got 3 scripts to turn in. 1, 2, and 3. To turn in all of your scripts that you turn in are going to have the .py extension. It is actually possible to save something in IDLE without putting py on the end. But until you put py on the end, it doesn't like do all the coloring for you. So put py on the end and make your life easier. So this is the way I want you to name all of your scripts. So you're just going to say your last name. So write Ray. I would write Rayber. You don't write Rayber. Last name underscore, and then your first name. So I write George, and then underscore, and then write the exercise number. So the exercise number is the this is the second week. So this will be 2. So this is called M2. So write 2. So Rayber, George, 2 underscore the script number. So you'll have 1, 2, and 3. Okay? So you're going to have, that's going to be the name of your first script, that's going to be the name of your second script, and this is going to be the name of your third script. So you have 3 scripts, you'll zip them together and submit them on Canvas. That's what you'll turn in. Okay? All right. So let's start. We're going to write, let's see. Yeah, go ahead.
Sorry, Canvas does not really require you to zip. We just do want us to zip.
Oh, it doesn't? You can submit multiple files?
Yeah, you
But I don't care if you submit multiple files. Yeah.
You have a little thing on Canvas on your assignment. When you are determining the assignment, you can say if the person can submit, resubmit, not resubmit, and if the person can submit
Multiple files. Okay. So maybe did I set it up that way?
I mean, the other courses that we took last semester was set up that way.
Oh, okay.
So for JS, we never had to zip.
Oops, that one doesn't have any. Okay, so yeah. I said file uploads. It is plural. I don't see where I set up multiple files, but I guess you can do multiple files. Okay. Anyway, if it works, it works. I don't care if you zip it up or not. Some students have asked, hey, there's multiple files, how do I do this? So that's why I said it. I've never tried to submit anything on Canvas. Back when I went as an undergraduate, we did not have it. Email was actually a brand new thing when I was an undergraduate. I got an email address like halfway, well not halfway through, after my freshman year. All right, I still have a 3-digit email at my undergraduate, it's just GTR. So, and then even at my graduate institution, I was just GR. That's a pretty small email address at sc.edu. All right, I'm sure they've given my email address to somebody else by this point. All right, so we're going to do one. And with 1, we're pretty much going to work mostly through it. And then with 2, we'll start it. You guys have to finish it. And 2 has a lot of the same logic as what we did today. In fact, really, what 1 and 2 are doing is really similar to what we did, except for we're not creating a function that finds which one's bigger. Yeah, go ahead. Okay, when we get to there, I'll bring it up and I'll scroll to there. I'll bring up the book on the laptop. Okay. Yeah. All right. Actually, let's see. So sorry, 1 is a lot like what we did today, except for instead of finding whether or not 2 numbers are bigger, you're just going to find out if 3 numbers can form a triangle or not. Okay? So that's really similar to what we did. Number 2 is different, like you said. In fact, maybe let's start, because we got limited time, maybe we'll start with 2, and we'll just go right to your question. We'll start with 2, because 1 is so similar to what we did, except for we're not trying to find the length between 2, we're not trying to find whether or not 2 are bigger, we're trying to find out whether any 2 are smaller than any of the other 1. Any 2 combined are smaller than 1. So it's a little bit different logic, but pretty much the description here is exactly the same, except for you're not saying is it bigger, is it a triangle, is what you're trying to do, and you're just asking the user to enter 3 lengths, convert them to integers, and use the triangle check to see whether the given lengths form a triangle. How do we convert something to an integer? It's int instead of float. All right. So yeah, since that one's so similar, we'll get to that one last, because I believe you guys can do it just with the example code that we did today with the is bigger, which is bigger. So you just change it to is it a triangle, and work through that. Okay. So let's look at the book.
So we're starting with script 2, Dr.
We are. We're going to start with script 2. Okay, so I said it was on 53, and it's not on 53.
It's page 52 in the PDF, or page 74 in the PDF. Section
6.2. Which page is it on, sorry?
So on the PDF.
Yeah, I'm in the
Page
PDF.
number in the book is 52. The page number in the PDF is 72.
Oh, okay.
Yeah, 54.
Yeah, 50. So it's not page 52. So it's right here. So yeah, that's the mistake that I made. Is that I said it was on page 53, and it's the PDF is numbered, but the book is also numbered because there's so much like table of contents and all that stuff. So this is the function that I'm not the function. Actually, that's not it because that one just returns 0. This is actually the function I'm talking about right here. Okay, so that's the function. We're just going to copy and paste this in there to start off with. This function takes 2 numbers, 2 points, and returns the distance between those 2 points. What's a point? How do we define a point? An x and a y, right? So x, y, we just need 2 points. Those define points. So I'm just going to right click and say copy. We're going to have to clean it up a little bit. It's not going to copy into Python perfectly. So I'm going to go back here. I'm actually going to close up the other things. I'm going to close up everything except for this. And then say File, New File. I'm going to paste that into there. Okay? What's wrong with it already? Right, it's not indented. So I'm gonna save this in C temp SPA M2, and I've already done this, but in each case these aren't completed. So I've got Raber George 22, and then to clarify that this is this year, I'm I'm going to write 218. But I left each of these kind of blank. Well, they're kind of like left to finish, and we're going to do the same thing today. Okay? Sometimes they'll be similar to the last time I taught the course. Sometimes they'll be different. This time they're very similar. All right. So that's all I need to do to straighten that up. I want to see if it works, though. So what can I do to test to see if this works? Now, we don't even really need to know what this function does. You don't need to understand the math, but we could, right? I mean, a squared plus b squared equals c squared. So all this is doing is taking the distance, the x distance and the y distance, and finding the distance of the two legs, right, of the triangle. That's the difference between the x's and the difference between the y's. That's what it's doing. And so we have two numbers that are the difference in the x and the difference in the y. We square both of those and add them together. And then we have the square of the hypotenuse, which is really the distance between 2 points. And we take that, and we take the square root, and we get a result. And that result is returned. Okay, notice that I've used math. So what do I need to do to actually get that in there? Does anybody remember?
Import math.
Yep. So we're going to add an import math. And then to test it, we can just call it distance. And let's feed it some numbers that we know will produce some good numbers. Now notice that it doesn't actually change these numbers. So let's feed it floats so that it doesn't screw it up. Because if we didn't feed it floats, it would, it'd be okay for part of it, because it will return a float no matter what, because math returns floats. But let's feed it non-floats. And let's feed it floats so that it gives us the right numbers to begin with. So we got, I'm going to go 1.0, and then 2.0. So that's like 1, x is 1, y is 2. And then for the second x, I'm going to go up 3 units. So that would be 1 plus 3 is 4, 4.0. And then I'm going to go over 4 units from 2, so that'd be 6, 6.0. Anybody know why I did that? What's that? So, there's a few neat triangles that always have integers. A triangle that has a right triangle with sides 3 and 4, the third side will be 5. So there's a few of those that are even numbered. So I knew that was one of them. That's why I picked that number. So this side right here from 1 to 4 is 3, and from 2 to 6 is 4. So I knew the right answer. So that allowed me to test to see. It's just, oftentimes when you're testing your code, it helps if you know the right answer, if you know what you're expecting. Okay, so if you need to work it out by hand, you can do it, or if you know something like that. So this function, I can call this function, and I can always get the distance between these 2 points. So this represents a point, and this represents a point. 2 points. So 1, 2, in space. Like let's say I had a Cartesian coordinate system. I still got paint up from before. Everybody that's not in my error class is like, what is that? So if that represented Cartesian coordinates, if I went over 1 unit and up 2 units, that would be my point right there. And then if I went over 4 units and up 6 units, okay, And so what this is doing is finding this distance, whoops, but more of a straight line, and this distance, and then it's using that Pythagorean theorem to figure out this, which is the shortest distance between two lines. Okay? I mean, again, you don't really have to understand the math, but it is pretty basic math, and that's how that works. Okay, so what are we doing with that? Okay, we're going to write a program that calculates the length of a polyline. What's a polyline? A polyline, like in ArcGIS, is a number of connected line segments. And it's going to use a while loop to continually prompt the user to enter a new vertex along a line. So each time the user should be asked if the polyline is complete. If it is complete, report the length of the line. So they're always going to be able to ask to have a new set of points. So you're going to enter a point, then you're going to enter another point, then you're going to enter another point. And after each time you enter a new point, you're going to say, is this done? Okay? And obviously, if they just enter one set of points, how long is the line? What's that? Just one set of points, an X and a Y. How long is the line if they just enter one point? Yeah, the line's length is 0, so that needs to be reported as 0. And then once they enter the second set of points, then we can calculate back to the second set of points and so on. All right? Okay. So we need to
They
figure...
don't have to enter 4 different points.
No, they can stop after the first one and they just get told the line's length is 0.
Okay.
And if they stop after the second one, the line's length is the distance from the first to the second. Now, okay, we could wait until we got all the points, right? And then figure out how to get back. And that would actually work better next week when we use for statements. Since we're not using for statements yet, I'm just going to go ahead and let you in on the way I think would be better this time, okay? I think it's better every time through the loop to calculate the distance and just keep a running total of the distance. So when they provide the first point, the running total is 0. When they provide the second point, we calculate the difference between the first point and the second point, and we add that to the running total. And then we calculate the difference from the next point we get. We calculate the distance from the third point back to the second point, so we don't even have to keep track of the first point anymore. So we're always only keeping track of the point that we're on and the previous point. That way we don't have to keep track of a big series of numbers, because we don't have that skill yet. But we will next week. But for now, all we're going to do is keep track of the last point and this point. Okay, last point, this point, and we keep a running total of the total. So this will help us with a skill that's in a loop, keeping a running total, which is fairly common thing that people do in computer programs. And so first we need to set up our loop. And let's think about what we need to do in each side of the loop. So we're gonna say while, and it's going to be similar. We'll come up with the condition later, but it's going to be kind of similar to what we just did, where we're asking for 2 inputs, right? And so as long as they say they want to continue, then we keep going. So we'll come up with the condition later. So inside of here, what we need to do is a few things. I mentioned that we need to figure out the distance from the current point to the previous point. That's one of the things that we need to accomplish inside of the script, inside of the loop. Okay? And then we need to output, or let's say we need to add that distance to the running total. So we need to figure out the distance from the current point to the previous point, and then we need to add that distance that we get to the running total. And then another thing that we need to do is find out if they want to continue.
So Dr. Raver,
Yeah.
This is how you do your pseudocode. You just type it in as comments first instead of scribbling on paper.
Yeah, this is, I like to do it this way. I mean, you could write it out on paper if you wanted to, for sure. If they want to continue, ask for another point. And then, if not, report the total distance. All right. So that's all we need to do there. I'm pretty sure that fulfills the requirements. Using the function write program that calculates the length of a polyline, as well as we can only prompt the user for a new vertex along the line. Each time the user should be asked if the polyline is complete. Okay, if it is, it reports the length of the line. That'll work. All right. So we need to fill this out with code logic. Okay. Because this is just like an algorithm, a basic structure. You use the word pseudocode. It's not really code yet. It's not even close to code yet. This is just a description of the process. Okay. All right. So let's dive into each one, and then we can kind of figure out what we need to put in. All right. So let's figure out the distance from the current point to the previous point. How would we do that? We have a function to do it, right? Well, first of all, actually, I left out a step. What do we need to do first before we figure out the distance from the current point to the previous point?
Get the input.
Yes, we need to get the input. So, have the user give us a point as two numbers, x and y. Okay, so that's pretty easy. We've done that before. We could just say x equals raw underscore input x value for point. There we go. The point along line, something like that. I'm just going to cut and paste, get a y value. All right, so just for brevity, to show something a little bit different, I'm going to do this. You can nest functions. This is possible. This is part of composition too. Okay. So the disadvantage of this is it doesn't allow me to put it into a try statement. Okay. But the advantage is it'll stop. It'll kick him out and have him stop it right then. So x equals float raw input. So it's just nesting two functions. This function returns a string, and then that string gets immediately put into this function that's going to return a float value out. So we're making them put something in that's a float. Yeah. Go ahead. Oh, good question. So the question was, why do I have two parentheses? Another thing I'm going to change is this. The reason that I have two parentheses is that this parenthesis closes this, and this parenthesis closes this. So it's it's, yeah. I'm just basically combining two functions together, nesting two functions inside of each other. I mean, we could get ridiculous and actually combine the function that calculated distance with those. But that would, like, we could put both of the raw inputs inside of the function that calculated distance and just write a really, really long statement. But at some point, I already think this is like too much. I would normally put these in 2 lines. I was just trying to show something different. Okay? But the next step is to figure out the distance. Right? So, how do I figure out the distance? Let's type in distance, right? That's the function. So, what's that? The square distance. Well, this is the distance. This is the real distance. It does calculate the square distance, but then it takes the square root. But I'm going to use this function to calculate the distance. But I need to enter 2 points. The second time through the loop, it'll be great because I'll have the previous point, right? But now I don't even have the previous point. So how am I going to get the previous point?
Wait a minute.
It's the point of
The previous point is 0, or the current point would be 0, right? Nothing's been entered, or
Nothing's been entered. Is it 0? It's 0, 0. This is going to, oh, here, I'll use this. Well, actually, let's just get rid of that. Okay, so let's say they entered 1, 2. That's here. If I used 0, 0 as my previous point, then my line's always going to start at 0, 0. That's not really where I want. Okay? I want to start the point here. And so the previous point is, what's that? The point they entered. And the current point is the point they entered. That'd be one way to do it. If we just said the points were exactly the same, we duplicate it. So we could remember we talked about setting up an initial condition? We could set up an initial condition, right? We could set, we have to call these a different variable, like we'll call them pre-x and pre-y, which means previous x and previous y. There's no reason to make them short. Well, yeah, there is. We could set these equal to something that is obviously different than any other value that they could put in here. Got any candidates? So,
x equals 8.
and then
sorry, what did you say? Well, yeah, the first time it's going to be, there is a few different ways of doing this. So I think what the path that Elliot is kind of on is that we could actually put a condition in here that says, if this is the first time through the loop, make x and y equal to, previous x and y equal to x and y. So that would be one way to do it, right? And the path that I was trying to take you down is perhaps maybe we could make pre-x and pre-y equal to like some string value, like yes or no. And if either of these are empty, and if either of them equal to empty, then it would assign them to be the same number as there. But in any case, we need an if statement right here. So in both of those scenarios, we need to put a condition, test if there is a previous x and y. Really, we only need to test one or the other. But and if not, assign 1. All right? So, so what we could do, I kind of like Ellida's solution a little bit better. So what we could do is come in here and say, first time equals true. Okay? And then come down here and say, if first time, and then put our previous x is equal to x, and previous y is equal to y. So if this is the first time through the loop, then it's going to run this. If it's not the first time through the loop, then it won't run that. So somewhere we need to change first time. In fact, we could just do that as a else. So now, the second time through this loop, first time will equal false. Whereas the first time through the loop, it equals true. So as soon as anytime it gets to this line, it'll execute it, and then if it's not the first time through, it'll equal false. Actually, I've noticed a logical error. What happens the second time through the loop? What's that? The second time through the loop, what's the value of first time? It's still true, right? This else statement doesn't need to be there. That was wrong. Sorry. So just like that. So it'll come through. It'll evaluate this just the first time, because the second time it won't do it. It won't hit it because it'll already change it to false. So that needs to not be an else statement. I was wrong. But I was going down a different way. I was thinking of a different way of doing it because of Ellida's suggestion than I was going to do. So let me explain that real quick. So up here, I was just going to put previous x and previous y and set them equal to some dummy variable, like
Dr. Avery,
empty. Yeah, or not a
you
number.
might use mouse so we can see what specific line you're,
Yeah, okay. That's a better idea. Sorry. So I was thinking up here of just putting these values up there and then testing to see if they were some value like empty. If it equals to empty, then if they're equal to empty, just change them to x and y. All right? But anyway, so the first time through, the values of previous x and previous y are just going to be the same, so that when it calculates the distance, what's the distance going to be? What's the distance between 2 points that are exactly the same point? Yeah, exactly.
Dr. Raber, when
Yeah.
you do that first time test, wouldn't you go ahead then and print what the distance is so that it's in that nest? Or not, just leave it for our next, for the...
I think it's a great thing to do for testing. We don't it's not necessarily required for the thing, but let's call this cdist because it equals current distance. And I think it's a great idea. So let's say pre-x, pre-y, which looks like pre, x comma y. Okay? So cdist is going to equal that, and yeah, I think it's a great idea to print that out. So the current distance will always be reported. I think that's a good idea to put a print statement there. So that's the distance from the current point to the previous point. The next thing that we need to do is add that distance to a running total. So how would we do that? How do we create a running total? It's
Counter variable.
yeah, we need a variable outside the loop. So it's another precondition. So we set up a variable outside, and let's call it total distance, and set that equal to 0, because it makes sense to set that equal to 0, because it's going to be the total distance along that line, and so it starts off at 0. So now, let's add the distance to the running total. How would we make sure the total distance is always the total distance each time? So we start off with total distance equals c distance, right? That's right. Do we need anything else? If we do this, every time through the loop, total distance will equal c distance. So let's think about this. Let's say the first time through the loop, c distance is 5. It's 5. I think you're right. I'm just going to explain it a little bit. Let's say the first time through the loop, c distance is 5. The second time through the loop, c distance is 10. What should total distance equal? 15. So it should equal the current distance plus the total distance. So each time through the loop. And I'm still having trouble recognizing your voices, telling your voices apart down there. Who suggested CDIS++?
I think I was wrong, but wouldn't it be total distance plus equals c distance?
Yeah, that's exactly right. So C++ just adds 1 to increment. So yes, you can do plus equals. It's just a shortcut. Okay. So yeah, we still need to do a few more things logically. But instead of that shortcut for now, I'm just going to leave this total distance so that because it's better to think about it. It's better to think about it like this. You can shortcut it later. So plus equals is a shorthand for total distance plus c distance equals c distance plus total distance in Python and a few other programming languages too. All right. Find out if they want to continue. Do you want to continue? That's the next thing. Okay. So there we need to just enter the exact same logic we had before. We could even, well, let's do it a little bit different. We'll just say raw input. I'll just call it CONT for continue. Raw input, raw underscore input. Do you want to continue? Question mark. Quote. All right. And then so if they want to continue, then we need to ask for another point, which means we need to just loop through again. If not, we need to report the total distance. All right? So this is like 90% of the way through the code. All right? So I'm gonna stop there, and I'll upload this example. But they want to continue to ask for another point, yeah. So yeah.
Don't we need to, similar to previous example, have an enter y or x and set it equal?
Yeah, that'll be more elegant. You're right. Enter y to keep going. Like that? What you're saying?
Yes, sir.
Yeah. All right. And so, it's really pretty easy to do from here. What you need to do is put an if statement. If, well, here, since we'll say that. If CONT equals y, right, then if it does equal y, then, 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 if it does equal y, then then actually, we could say pass, right? I mean, we could just not do anything. And then else, if it's not true, write print total, oops, distance. And now I'm like completing it all, but print total distance. I should actually put this comment right here. And then we need to do something. Okay, this is what I'll leave for you all. Okay, so the condition isn't really a condition yet, right? We need to make sure that this condition is set up. So you might have to set up a a dummy variable at first. Not a dummy variable, but a precondition like continue equals true. You might have to set that up right there. And then you would make sure that you said continue equals false down here. Okay? And then it should work. Hopefully it works. I didn't even try to run it yet, so it may not work. All right. So yeah, try to make that work. Run it a few times. Try to get it working, and then in about 10 minutes, I'll change it to the solution, and then we'll talk about the other question. And because the other question, you may look at it and think this is really confusing, and it may be difficult, but really it's the exact same question. All you're doing is changing the function that you call. That's all you're doing, is changing the function that you call. But we'll talk about that in a second. All right.
So we're doing assignment number 2 right now, right?
Yeah, we're doing assignment number 2. I decided not to focus on assignment number 1 because assignment number 1 is almost exactly the same as the example that I did in class today. The only exception is that you're testing a different function. You should be able to do that one by yourself. So right now, though, focus on assignment 2. If you have any questions from the coast or from here, raise your hand. I'll come around, or you all can send me your code, and I'll try to figure it out here. And in about 10 minutes, I'll just stand right here or go around and help. Then I'll post the solution. Then I'll come up with the solution that I come up with. Anybody got it running already?
I'm gonna get syntax errors.
Okay.
On
Probably because
this water.
Oh, you don't have a second. You don't have a second parenthesis. That's it. Well, it's not gonna, condition doesn't, what word is it saying? If you don't, this, parenthesis, yeah, outside of it.
When I'm defining the condition true and false, is that outside of the
Yes, so you need to set up something that is true before it enters the loop. Like, you could call it continue. So continue equals true. So you need to set that up before the loop. Okay? Well, let me just do that. So that's a question lots of people are having. All right, so the first thing that you need to do is set up something called continue continue is a key word. So we'll call it, we already called something CONT.
Start.
I'm going to call it keep going. Keep going equals true. So while keep going is there. So now you need to set, now all you need to do is in the right place here, you need to set keep going equal to false. Somewhere in here, and you'll be done with that one. So figure out where to put keep going. Let's see if we can make this bigger. In fact,
Can we have it to where we get rid of pass under if count equals y? I put if count equals y, keep going equals true, else print total business. Is anything other than y is false?
right, but you need to have explicitly set keep going equal to false somewhere.
Yes, sir. Okay.
So where would you put that?
I have it in my global variable area. Right under total.
I see what you're saying is what you're
I call mine start. I said start equals true right outside my while loop.
okay, but did you write start equals true here?
No, after that, I put if CONT equals y, start equals true, else print total business. If they hit anything other than y, like x or whatever, that means they don't want to continue.
Right, but you need to explicitly state start equals false somewhere. Otherwise, it's going to keep going forever.
I got you.
So, what's that? Yeah, you could put it in the else statement. Exactly. Okay? So that's it. So whatever you call it, he called it start. That's fine. I'm going to call it keep going, and I'm going to say equals false. So that has to equal that. And so what I'm trying to say is that keep going doesn't need to be explicitly equal to true because we set it equal to true before. So it's going to keep going. We could say keep going equals false. Maybe a more elegant way to write this. Well, let me just see if this runs first. So 4, 5. First time is not defined. That's probably because I spelled first time wrong. Yep. So it didn't run. I'm going to try to run it again. You got to spell everything right. It's not a... Okay, so yeah, I want to continue. The distance, what's that? It's because here I have to put a capital yes to continue. So now 8, 9. Actually, it's still not going to work. Okay, why doesn't it work? We forgot to do another thing. There's another step that I forgot to do. Previous x and previous y, if it's great, if it's the first time through, they just equal the previous time. The second time through, what do previous x and previous y have to be? Right. Right, and so that needs to actually go here in the past. So previous x and previous y need to be set. In fact, it's going to be like this. You're going to use the exact same code. So previous x is going to equal x. That way, when it comes back up here, and it gets to this point, pre-x and pre-y are going to be these x's and y's from the time before, and x and y are now going to be the new x's and y's from up here. It's going to go back through. So I'm going to try to run that, and this should work. So let's go 5, 7. Do I want to continue? Yes, I do. 8, 9. Didn't work. What's that?
The last part of it, after the if continuing equals y.
Yeah.
The pass button.
No, I don't need the pass there.
Mine
works, and I have
Oh, I'm printing the C disk. Printing C disk. Yours works and you have what I have. That's great. Okay.
Yeah, I probably couldn't have said that.
All right. Well, I'm going to debug my program by looking at the values of previous x, previous y, x, and y each time through the loop.
Dr. Reaver?
Yeah.
You spelled time differently.
I did.
And
Where's that?
you use two T's, and then if you can, on the next block, you use only one T.
Yes. Okay. Yeah, so that was probably the problem. Where's that first print? I'm going to take this print statement out, because that's not required. That's just a test. Okay. So 6, 7. Yeah, keep going. 8, 9. Cool. That works. Yeah, I want to keep going. 10, 15. So that running total is now working. No, I don't want to go. I don't want to stop. Or sorry, that's not a running total. That's just this is the total, which is the total of these 3 values. Okay.
So you're saying it should say 5.0, then the next value is point along line on the first time you're doing it?
Well, that was just a test. The 5.0 thing that was up here was a test of distance.
Oh, I see.
Yeah. So I took it out because we didn't need the test anymore.
Are you talking about print CDSD?
Print what?
I found it.
Okay. And this is also just a test of the code, but it's fine to leave that in there. Now, technically, I said that you needed to be told the total distance in a complete sentence. So there is one thing left to do, although it's really, really easy. You need to change that print statement so that it says something like,
Well, in this one, you would say the total distance of the polyline is.
right,
And then
exactly.
the total distance.
That's exactly
The
right.
other one was a triangle, this one is a polygon, right?
Yeah, so you need to put a statement that says the total distance of the polygon is, or the polyline is, and then the total distance. So remember, you're going to have to convert this into a float. Into a string. All right, so here is what I was trying to show before. I'm going to try to make this, how come I can't make this smaller? It's really, really lame. Is that like the smallest it's going to make it? Anyway, once I take that out of there, I'll be able, these will all upload, but I don't want to take the video recorder out. But once I do, I'll be able to upload it. So I'll upload it right after class. And then those will be there. Actually, maybe if I just started and stopped it. Nope. It looks like it's requiring it to be this window a certain size, and it's not letting it be any smaller. So I can't actually put it up online until I take the video recording software out and my screen returns to its normal size. Okay. So that is that's almost entirely question 2. We worked through question 2 almost entirely. So that was a little bit more complicated. Question 1, you'll be able to do if you look at the example that I'll post later from class today. Okay? And just think about the trying. You're going to have to write a few more if statements because you're going to have to check if A and B is greater than C, or if B and C is greater than A, or if A and C is greater than B. You have to check all three of those. And you could use an AND statement to find out if any of those are true, it won't form a polygon. If any two segments are shorter than one of the other segments, no triangle can be made. So you might have to test three things and then say if A or B or C is true. So you say if A or B or C. So C is equal to if these two are smaller and anyway. So there's a few more if statements, but you can do it. Okay. So instead of going back up to this one, because I think that one's actually the easiest one, let's move on and look at this. This one's kind of like a geographic problem. So 3 is calculating the distance on a spheroid is different than Cartesian coordinates. We've done Cartesian coordinates in 2. So I want you to use the Hattersheim function, which is there. I have it. We're going to modify the program to calculate the length along a sphere rather than the length along a in Cartesian space. So like my hand's not a sphere, but the distance for like from here to here on a sphere, you go like that rather than straight. So there's totally different math involved. In fact, it's a lot more complex math, but it's still just math. And you don't have to understand it all. But here is, right here, Haversine.pi. This is the function. Okay? Now look, what you have to do is copy this whole thing into your code. I'll just copy it all in a second. Well, actually, I'll just copy it all right now. So copy.
Which function? You got two functions, the first and the second.
You're going to copy the entire code block, everything, both functions, into a new code. So I'm just going to say copy, and I'm going to bring it in to, not to there. I'm going to bring it into a brand new thing. So I'm going to say file, new file. I'm going to paste it all in there. Okay? And then when I actually go to say, I'm going to save it as, I'm going to save this as Raber 2018, but I'm going to save this as 2_3. All right? And then I'm going to run this. Okay? And look, the output of this, right now, this is the only line of code running. You don't even need to understand anything above this point at all. Okay? Just accept that this is calculating the distance between 2 points on a sphere. Okay? And that the numbers that you need to put in here are a latitude and a longitude and a latitude and a longitude. Or actually, it's the opposite. Longitude, latitude, longitude, latitude. Okay? So this is like, these are both points that are pretty close to us in space. Okay? Right? Not immediately close to us. There's a pretty far difference in latitude, but longitude is not that different. Okay? So we're talking about somewhere in Mississippi to somewhere out in the Gulf of Mexico. Right? And the result is going to be in kilometers. So the result's in kilometers. So the math knows that it's in kilometers. So you just give it a latitude and longitude and a longitude and latitude, longitude and latitude, and it gives you points. It gives you a distance. How is that similar to the function that we've already used? It's a distance formula. It returns a distance, and it expects 2 points, right? The points are expressed in latitude and longitude, but they're still just points, right? In computer science lingo, this function, points to distance, could be said to have the same signature. In other words, it requests the same parameters, just calculates things differently and returns a different type of result. In this case, it's almost the exact same result. So print points distance, this function is the same. So what you need to do here is to simply, this can be removed when you finish it, is to simply take this code that you've already created, copy it all except for the distance part, and put it in this code, and hook it up so that instead of using distance, it uses points to distance. It's going to use a different function. But in the end, it's going to produce the same thing. It's just, you got to change a few things. I would suggest you change these words to latitude and longitude. But you don't actually need to keep, you could change the variable names if you wanted to for your sanity, but there's no reason to. You don't need to get full credit for the lab. But you should probably change these. You could say, you could change the whole prompt so that it wasn't points along a line. And then what you're going to do is calculate the total distance hopping from city to city, or not city to city, from point to point on the globe.
Where did you paste that in at the very end of the code?
Yeah, the very end of the code. Right. What's that?
And this third code, will it be cumulative?
Yeah, it'll still be cumulative. The total distance will still be cumulative. It'll be, so get the first code working, and then do the next one. Really, it should be easy. All right. Any other questions? And then do number 1. What should be the easiest one? And we did almost all of 2. Really, all you need to do is make it a complete sentence and you're done. And then 3, you're just calling a different distance function. That's the easiest way to put it. Okay? And then at the next class, we'll go over and make sure, it worked for everybody. Okay. And then if anybody wants to work on it right now, I'll be here until a little bit after 5 to work on that. All right. Any questions right now? That was a good question about where to put it.
How do I open up a save file? If I double click it,
It tries to run it. It tries to run it in the program. So
edit with IDL.
yes, edit with IDL, or you can just open IDL and say File Open, and then navigate to it.
And then type your save file name.
Yes, File Open, and find it. Does that make sense?
Yes, sir.
Okay, if there's no more questions right now, another thing I'm going to do to help you guys is stop recording, and then I'm going to upload all these to the class website.